Hello and welcome to this video on proof by induction. In this video we're going to be looking at an example with a divisibility test. So we've been asked to prove by induction that 19 to the power n minus 7 to the power n is divisible by 6 for all positive integers n. And just like in the series sum video, we're using the 4 steps. Step 1 the base case, step 2 the assumption, step 3 the inductive step, and step 4 the conclusion. So starting with our base case, when we look at n equals 1, if we call f of n, define f of n, the function, as 19 to the n minus 7 to the n, where n is a positive integer, then f of 1 is just 19 to the power 1 minus 7 to the power 1, which of course is 12, and we know that 12 is indeed divisible by 6, so it works for n equals 1. Our assumption is that, again, we're using n equals k, so replacing the n's with k's, we're defining f of k as 19 to the k minus 7 to the k. We're assuming that is divisible by 6, and another way of saying that is that f of k is equal to 6 alpha, where alpha is a positive integer. So when we do our inductive step, we'll be using the fact that f of k is equal to 6 alpha. Our inductive step, and again, that's one where we have to do some work. So defining the f of k plus 1, which is of course what we do in induction, is looking at the k plus 1th term. That'll be equal to 19 to the k plus 1 minus 7 to the k plus 1, so replacing the n's or the k's with k plus 1's. Now 19 to the power k plus 1 is the same as 19 to the k times 9 to the 1. That's how indices work. So we can rewrite that as 19 lots of 19 to the k, and we can rewrite 7 to the k plus 1 as 7 lots of 7 to the k. So we have 19 lots of 19 to the k minus 7 lots of 7 to the k. Now, we need to remember what our goal is. We're trying to get a factor of 6 out of this. Okay, now the first thing I want to do, or try to do here, is can I retrieve the original function? Because we know that is 6 alpha, or we're assuming it's 6 alpha. So if I split up my 19 lots of 19 to the k into 12 lots and 7 lots, I've got 7 lots of 19 to the k and 7 lots of 7 to the k, which I can then rewrite as 7 lots of 19 to the k minus 7 to the k, i.e. 7 lots of the original function. The good thing about that is that if we're splitting it into 12 lots of 19 to the k and 7 lots of 19 to the k, the 12 lots of 19 to the k is also going to be divisible by 6. So if you look through my methods, okay, on the second to last line, I've got that 6 lots of 2, that's 12 lots of 19 to the k, plus 7 lots of 6 alpha is equal to our f of k plus 1. Then I factorise out the 6, so we've got 6 lots of 2 lots of 19 to the k plus 7 alpha, but the important thing is that 6 outside the brackets. Therefore, f of n is divisible by 6 when n equals k plus 1. Then we just finish with our conclusion, which is exactly the same as last time. Since it's true for n equals 1, and since if it is true for n equals k, it's also true for n equals k plus 1, is therefore true for all n. Thank you very much.